Hey everybody. Today what we're going to do is we're going to work through something called the distributive property. You can see it up top. And what we're going to do is we're going to use the concept of area to examine something called the distributive property. So what we're going to do is we're going to work through problem 1, us dealing with this garden, and hopefully we can extend that into a new operation algebraically. So you take a peek. The question asks you to find the area of the entire garden. Now, I assume that you're okay for this. So we're going to work our way through this together. What I'm going to ask you to do is put a little wavy line on your page right where you see my wavy line. Because what I want to do is I want to deal with this two different ways. Just so we can speed up the process talking about the garden, I'm going to put some vegetables in that garden. So let's say that what we're talking about on, I don't know, the left side, we're going to talk about beans. We're going to grow some beans. And then maybe on the right side, let's grow some carrots. So we can now talk about like the bean portion of the garden and the carrot portion of the garden. So what I could do then, if I need to find the area of the entire garden, then maybe I just find the area of the whole thing in one go. Now, I'm going to write down some extra stuff. Again, I assume you know how to do this, so I want to examine something in detail. That is, I could say that the area of the garden, and since it's a big rectangle, is length times width. That is one dimension, 5, times the other dimension, all the way across 10. I could just multiply together those two dimensions. So I'm going to take my 5 and I'm going to multiply it. Now, I'm just going to put a line in at the beginning. I'm going to show the adding of the 4 and the 6 together, and you'll see why in a bit. Okay, what we would have done if I had just said calculate that is you would have found 5 times 10, and then that gives us our 50 and our units, meters squared. Now, you will notice something in that purple. I did not write an operation in between the 5 and the bracket, and I know when I don't see an operation, that means multiply. Okay, that just speeds some things up for me as I go. Let me get rid of that, and we are good. Okay, on the right side of that wavy line, what I'm going to do is I'm going to get down an alternate solution. And that is, what if I calculated the entire area by adding together the two smaller areas? That is, what if I viewed that as a composite figure? Well, I could say then that the area was 5 times 4 for the beans, plus 5 by 6 for the carrots. And now what I can do is I can calculate the individual areas and add them up in the end to get my total. Okay, I'm hoping that we're good with that process. And I'm hoping that if I had let you go on your own, you would have been fine to come up with both. Okay, why am I doing this? Okay, what I want you to do is I want you to take a look at the next problem. Okay, you'll notice one big difference. Now, if I just go back to beans and carrots, let's say that, you'll notice that one of those differences, I don't know the length or the dimension of the beans garden. Okay, so why do I say that? Well, I'm going to put a little wavy line down again. And if I wanted to, I could go through and I could find the area of the entire garden. So I would work through and say that my area is my one dimension times my other dimension. Now the problem becomes, I don't know what all the way across is because I don't know what x is. So the most I can do is I can say that the length of that garden is x plus 6. And then I hit a bit of a snag. Okay, I'm not sure what to do with that purple. Okay, what if I examined it the other way? That is, what if I said that the area of the entire garden was a composite figure? Then what I could do is I could say it was the area of the beans, which would be one dimension times the other dimension, so 5 times x. You'll notice I could have put brackets around that x to show the multiply. I really don't want to write this 5 times x, because now my multiplication symbol looks like my variable. So I don't want to do that. I don't need brackets around, because if I don't see an operation in between, I know it means multiply. There's my simplified form for the area of the beans. Okay, what I can do is I can then go through and say, well, 5 by 6 is the area of my carrots. And when I look at that line, I can't simplify 5x at all because I don't know what x is, so I can't calculate what 5 times x is. But I can calculate 5 times 6. And that gets me an area for the entire garden, a little more simplified. Okay, why are we doing this? Because I want to draw to your attention that that purple equals that blue. And so when you take a look back at the purple expression, you might be able to see a way that we can simplify it. If my purple equals my blue, then the way I can make my purple change into my blue is to do the multiplication operation. I cannot do the addition. I cannot simplify x plus 6 because those are not like terms. So I move on in BEDMAS. Now I can do my multiply. Well, in order for me to do that multiply, I'm now going to take my 5 and I'm going to multiply it by my x. And then I take my 5 and I multiply it by the 6. And you'll notice we come in on equivalent expressions. Okay, that was us using something called a distributive property. Let's jump into that a little bit more. Okay, what you see at the top of your page, don't get distracted by all the colors, but what that is an example of the distributive law, or distributive property. Don't get distracted by the plus or minus in between the B and the C. I just needed to show that either of those operations are going to separate terms. And so whether it's an add or a subtract in between those doesn't really matter. How can I go through and simplify A times B plus C? Well, I can expand my brackets. And that's what that purple is often referred to. Take my A, multiply it by my B, then take my A and multiply it by my C. You could see in the earlier area problem, we get the same expression. Okay, let's just do one little numerical example so we can confirm that that statement is true. So what you see in problem 3 asks you to evaluate. And it's important for us to remind ourselves that evaluate just means calculate. So calculate for x equals 3, the expression 2 times x plus 5. Okay, we have two ways we can do that. Number one, what we can do is we can sub x equals 3 in wherever we see the x in that expression. So we have 2 times, and where we have our x, we can replace it with a 3. And now you'll notice you'll be able to follow BEDMAS. You can now do the operation inside the brackets, and we can now do the multiply. So we know that for an x value of 3, the value of that expression is 16. Okay, let's tackle a different way. So or. What if instead of subbing in, then simplifying, we did the opposite order? Let's simplify first. So what we're going to do is we're going to take that 2 and we're going to expand it into the brackets. That means I need to take that 2 and I need to multiply it times everything inside the brackets. 2 times x is 2x, 2 times 5 is 10. Now that we've simplified that, now we can substitute. And we're going to sub in an x equals 3. Now that means I replace my x with a 3, and now I can follow BEDMAS. 2 times 3 is 6, and 6 plus 10 is 16. So we get the same answer. It gives us a quick little confirmation of the distributive law. And there we go. Okay, the rest of today is just getting really, really comfortable at using the distributive property to expand brackets. And then see some of the little nuances that we have to consider as we're working through this language. Okay, let's jump in. So let's take a look at the first instruction. It is expand. Okay, that means we do the operations we can, and we're going to focus in on the multiply. So we take a look at the expression in A, and you'll notice you have two operations, addition and multiply. So we try to follow BEDMAS. And BEDMAS is going to say, do the operation inside the brackets first. Our only problem is we cannot calculate or simplify x plus 4 because we don't know what x is. So we move on to that next operation, that is multiply. And so for us to multiply, we need to make sure we multiply the 3 times everything inside the brackets. Those brackets really make that x plus 4 one big thing. So if it says take 3 and multiply it by that big thing, we have to make sure that we multiply it by all parts of it. Okay. So let's go ahead and expand that 3 in. We've got our 3 times x, and we have our 3 times 4. There we go. That's us using the distributive property to expand. Hopefully not that bad. Okay, I want you to give the next one a go. Okay, pause the video now, see what you can come up with. Okay, we're back. So we should be good. We cannot do the subtraction on the inside, so we are going to expand. 2 times 2m is 4m. 2 times negative 5 is negative 10. There we go. If we came up with that, we are good. Nice. Okay, one small thing. Take a look at your operations within your expanding. I don't think too many of us have a problem with 2 times 2m, but when we take a look at the 2 times the negative 5, we're actually calculating 2 times negative 5. You'll notice my signs are different there. That's why I have a negative between my terms. Okay, take a look at C. C is not more difficult, it's just more. Okay, I want you to pause the video, see what you can come up with. Okay, we're back. So, I need to expand. This time, I have 3 terms inside my brackets. So I'm going to take my time and work my way through the multiply. I got 3 times 5x squared. So I can multiply my coefficients, 15x squared. I have 3 times negative 2, so that's a negative 6 with my x. And then I have 3 times a positive 6, that is an 18. If we came up with that purple, I think you're doing great. I think that that's proof to you that you're good on expanding. Okay, so where do we go next? It's really just about us getting comfortable going through and working with uglier expressions. Okay, let's jump in. Okay, you take a peek at problem 5. Problem 5, I've expanded your instruction. Notice the first time, all we had was the instruction expand. Now we have the instruction to simplify afterwards. Okay, take a quick look over all 4 expressions, and you'll notice stuff's just getting a little uglier. That's all. Okay, let's work our way through. Take a look at problem A. The question asks us to expand. So I'm going to work my way through BEDMAS and do whatever I need to be able to simplify. Well, the first thing I'm going to notice is I have a number of operations. Add inside a bracket, subtract inside a bracket, multiply, multiply. So if I work my way through BEDMAS, BEDMAS is going to say, do the red. Do the add or subtract inside the brackets. My problem is I can't do that. because I can't collect like terms. So I'm not able to do that red. My next operation according to BEDMAS says do the multiply. So I can multiply because I now have the distributive property. So I'm going to do my purple. So I work my way through that purple, and I'm going to expand my 2 in. So there's a 2 times x and a 2 times -4. I cannot touch that plus yet because I have to make sure that I follow BEDMAS. So now what I'm going to do is I'm going to multiply my 3 in and multiply my 3 in. That first line, that is my expanding. Now, all I'm going to do is I'm just going to get rid of that blue and change that operation to purple so that I can just zoom out a little bit and make sure that we are good. That really all that is now, that purple line is me doing my expanding. So the only thing I haven't done then is my simplify. Well, now if you notice that purple line looks like old stuff for us. Now we can just go ahead and we can simplify. Okay, I'm going to collect my like terms. I have 2x terms, so if I go and collect those, I'm going to have a 2x plus a 3x, that's a 5x. And then I'm going to have a -8 plus 15. So if I lose $8, then I find $15, I am up $7. There we go. Take a look back at that solution for a moment, and you'll notice purple line was expand, red line was simplify. Technically, the whole thing was simplify because all I was doing was following BEDMAS. Okay, I'm hoping that that one felt comfortable. Take a look at the next 3, and I want you to try them on your own a little bit because I want us to see where we make some mistakes. Okay, problem B. Let's work our way through this 2 steps. What I want you to do is I want you to spend 1 line trying to expand it. Okay? Try to expand it on your own. Pause the video now. Okay, we're back. So if I did my expanding line, I can multiply my 4 in and multiply my 4 in. Now, notice the next operation. There are 2 ways to tackle this, but I really want to give you the easy way. And the reason why I'm going to call this the easy way is because it avoids double signs. Rather than just looking at this as a 6 that's multiplied outside those brackets, instead, let's look at it as a -6. You remember, the sign of every term is the sign that's out in front. So I could view that subtraction as also the sign on the 6. And if I do that, then what I can do is I can expand in a -6. So -6 times m and -6 times +3 is a -18. Okay, I'm going to put on another OR situation. And the reason why I want to put in a OR situation is I just want to show you the other way it can look, but the issue becomes double signs. So if your instinct was to look at that last set of brackets as minus and then just expand in the 6, what you now need to do is subtract the 6m and then subtract a +18. Well, if we subtract a positive, then we are making things more negative. You'll notice you're going to come in on the same expression as what we get. It's just going to take you longer. And you brought back in double signs. And I would not suggest doing that. So when we start to tackle expanding, let's start to tie the sign of the coefficient on the bracket with the coefficient. Expand in a -6 and a -6, and we'll be more efficient and less risk for mistake. Okay, there was my expanding line. Hopefully we're good. We should be good to be able to go through and simplify together. 4m minus 6m is a negative 2m. 20 minus 18 is a positive 2. Okay, that would be acceptable for us in our course. However, I really want to draw to your attention. Next level, we wouldn't accept that as fully simplified. You'll notice that if we change the order of those terms, and I wrote my 2, my constant, before my variable term, my m term, I actually get to write down fewer operations. That's why the blue would be considered more simplified. So I want you to practice that right now, that if you have your variable term that's negative, don't write it first. If you change the order, you could write down fewer operations. Okay, we'll see that in practice, and we'll get extra practice with it. Okay, your focus for right now, make sure you can get down to the red. Okay, let's work through C and D together. Okay, first off, I think in only a few problems we've gone through, I've probably already built up an instinct, and I want to break it. That is, I think I'm going to have a bunch of you that look at C and go, ooh, that looks weird. And it's because I put your monomial second and your binomial first. And notice that that is the exact opposite of every other one we've done. Like if I had written it this way, then the only difference between question C and all the rest are just the numbers are bigger. So let's make sure that we don't have to rearrange. If I have something times multiple things, which is what I have in all of my brackets, something times multiple things, then I know that I can expand that by multiplying into everything inside the bracket. So my expanding now becomes 5x times 12, which is a 60x. 12 times negative 8 is a negative 96. And you'll notice that that expanding line is also our simplified line. Okay, so takeaway from C. It doesn't matter what order we multiply it in. So you can expand in either direction. Okay, take a look at D. On D, let's just make sure that we don't make a silly mistake. Here's where I want to go right back to the operations in the expression. You take a look at D. We have subtraction. We have multiply. We have addition inside. A really common mistake is going to be to want to do that blue subtraction first and write negative 2, 5 subtract 7, and then multiply that by x plus 2. And we have to be very careful. We just broke bed mass. I cannot do subtraction before multiply. So I need to make sure that when I look at those operations, I don't touch that minus out in front. So what I need to do then is expand in my negative 7. So I'm not going to touch the 5. When I expand in my negative 7, I get that. And now I'm going to spend a line simplifying. I don't have any like terms with the x's, but when I calculate 5 minus 14, I'm going to be down 9. And there we go. Notice negative 7x minus 9, even if I rearrange those, I'm still going to have a negative 9 minus 7. I'm not able to write it with fewer operations, so there is no more simplified form than the red. Okay, there's us expanding and simplifying. Nice. Okay, let's look back at a couple other area problems just to make sure that we're comfortable with expanding. Okay, you take a look at problem 6. Write and simplify an expression for the area of the figure. Okay, I want you to give this one a shot on your own, okay? And then we'll come back and we'll check. So, pause the video now. Okay, we're back. So you start off this problem and maybe you said, hey, it's a box, so you know the area of a box is length times width. You never have to write that. That is a background formula for us. Please feel free to skip it. Just use it. So maybe your first line, if we are very literal to that formula, might be area is length times width. But you might not like the look of that because the monomial was second. Okay, I want to address a bunch of things in that line. Okay, first off, I'm going to get rid of that line, and I want to look at a few things that we could write that we have to make sure we're good with. If you wrote this, you are incorrect. And I want you to take a look at that purple line for a second, because I want you to notice where the only multiplication operation is. It's just between the 4 and the 5. And our problem is, to calculate the area, we have to calculate the length times the whole, the width times the whole length. One dimension times the other, not one dimension times only part of the other. So if I wrote that purple, I'm incorrect. Let's make sure we don't. So a lot of us are going to put in our mind, hey, I need brackets. Yeah, I forgot the brackets. And then the mistake is we write this purple line. I want you to notice that that purple line was the same as the previous one. The only multiplication operation is between the 4 and the 5. If we are going to try to multiply multiple terms times a single term, then we have to make sure that the brackets are around the multiple terms. Now that's a correct statement. Now I'm calculating my area correctly. Okay, I will have some people who don't like that. And if I was to tackle this problem, I would write it because that's just considered better form. You're going to see that more often. So don't feel like you have to be so literal on the area of a rectangle is length times width. No, it's just one dimension times the other dimension. Okay, there I have written an expression for the area. The problem is it's unsimplified. So we now know how to expand. I'm going to take that 5, multiply it in. Take that 5, multiply it in, and there we go. Nice. Okay, I'm hoping we did okay on that one. And I'm hoping that we ruled out a lot of the mistakes that we tend to have with brackets. Okay, let's tackle one more. Okay, you will notice this one more takes us back to a composite figure. Okay, just for the sake of uniformity, let's work our way through problem B. We do not have a formula for the area of that shape that doesn't really take into account regular shapes. So my advice to you would be, let's go ahead and let's break up that shape. And maybe a nice easy way is to imagine breaking up that shape into like box 1 and box 2. Okay, what I would like you to do, let's find the area of box 1. Let's find the area of box 2. And then you should be good to be able to come up with the area of the total in the end. Okay, I want you to give it a shot. Pause the video now. Okay, we're back. So for us to be able to work our way through, a couple quick things. If you do this way, you technically didn't follow the instructions in the problem. It doesn't end up hurting you, but I just want to draw your attention to it. If we try to come up with the area of box 1, well then it has to be one dimension times the other dimension. Nice. We could then go ahead and simplify that by expanding in the 6 and expanding in the 6. We could do the same thing on box 2. One dimension times the other dimension, and expand in the 2. Expand in the 2. Then, in the end, we could go ahead and we could say, well, it's 12x by 24 plus 8y by plus 18. And finally, in the blue line, did we write an expression for the area of the whole box? Because my orange was just me starting in bits and working separately, the first time I actually followed the instruction, which was write an expression for the area, is the blue. It's okay because you did follow the instruction in the end, and then you could clean that up, and maybe we take a 12x. There's no other y's, and the only thing we can put together is the 24 and the 18. That gets us up to a 42. That blue is our fully simplified expression. Okay, all I'm going to do is just shrink this down a little bit because you may have chosen to solve it directly from the very beginning. You could have said that the area of the total is the area of box 1 plus the area of box 2. You just did it all together. That is, it is 6 times 2x plus 4 plus my 2 times 4y plus 9. And you'll notice what you created was an expression that looks an awful lot like problem 5. You would have then expanded your brackets, collected like terms, and eventually got down to the same solution as the blue. 2 different ways to get there. Okay, I think we've covered enough with regards to expanding. I'm hoping you understand why we do what we do. And now your job, drill in as much practice to make sure that this operation within algebra becomes second nature for you. Okay, jump in and get some practice. Best of luck.